Hello everyone, welcome to Aquatic Maths. This is Pranjal and today we are going to start Chapter 1 of class 10th, that is real numbers. So let's begin with our chapter. First of all, before starting the chapter, let us first discuss the topics we are going to cover in this chapter. First topic is, we will just recall what are prime and composite numbers. After that, we will learn about what is the fundamental theorem of arithmetic. There is a theorem of arithmetic that is called as fundamental theorem of arithmetic. We will learn about that. Then we will discuss the HCF and LCM using the prime factorization method. Then we will discuss what is the relation of HCF and LCM of two numbers. If two numbers are given and the HCF and LCM of the two numbers are given, then how are they connected with each other? After that, we will learn a new term, co-prime numbers. Then we will move up to real numbers, rational and irrational numbers, and after that we will discuss the proof of irrationality. Okay, so let us just recall the prime and composite numbers first. See, the prime numbers. Prime numbers are the natural numbers that are divisible by only 1 and the number itself. What does this means? First of all, we all know that what are natural numbers? Natural numbers are the counting numbers, right? Counting numbers means those numbers which we use to count anything, like 1, 2, 3, 4, up to so on, up to infinity. They all are natural numbers, right? So prime numbers are those natural numbers that are divisible by only 1 and the number itself. Means it have two factors only, either 1 or that number itself. For example, 2. See, 2 is that number, it is divisible by only and only 1 and 2, right? It means it has two factors, 1 and 2. Means only 1 is the factor and that number itself is the factor. Similarly, 3, it also has two factors, 1 and 3, so it is also a prime number. 5, it also has two factors, 1 and 5 only, so it is also a prime number. Same 7, 11, 13, etc. These all are prime numbers. Means those numbers which have only two factors, 1 and the number itself, and they must be positive integers, or we can say natural numbers. Natural numbers are also known as positive integers, or we can say that positive integers are also known as natural numbers, right? So those natural numbers which are divisible by 1 and that number itself are the prime numbers, or we can also say that those positive integers greater than 1, positive integers are greater than 0, right? Those positive integers which are greater than 1 with exactly two factors, 1 and number itself. See, there is one more thing. Those positive integers start from 1, but here the prime numbers are those positive integers which are greater than 1, because if we talk about the number 1, then it has only one factor, that is 1, right? It does not have the two factors. But prime numbers must have two factors, 1 and the number itself. But in case of 1, we only have one factor. So 1 is not a prime number. Clear? Now, we have other numbers also except the prime numbers. They are the composite numbers. So now, what are composite numbers? Composite numbers are those numbers that have more than two factors. See, we have a lot of numbers, we have infinite numbers, right? Out of those infinite numbers, those numbers which have only two factors are prime numbers. But there are some more numbers now which have more than two factors. So those numbers are called composite numbers. Okay? So if we talk about, we learned that 2, 3, both are prime numbers, right? If we talk about 4, see, 4 has three factors, 1, 2 and 4. So it has three factors. It means It has more than 2 factors, so it is a composite number. Clear? Now 5, we learned that 5 is a prime number because it has only 2 factors, 1 and 5. Now next, 6. 6 has 4 factors, 1, 2, 3 and 6, right? So this is also a composite number. Okay, now if we talk about suppose 10. Now 10 has factors, 1 is a factor of 10, 2 is also a factor of 10 as 10 is divisible by 2. After that 5 is also a factor of 10 and 10 is also a factor of 10. So 10 has 4 factors which are more than 2, so it is also a composite number. Clear? Now see next, fundamental theorem of arithmetic. See, what is fundamental theorem of arithmetic? What does it say? Every composite number can be expressed as a product of primes. What does it mean? Every composite number can be expressed as a product of primes. We all know now that what are prime numbers and what are composite numbers. Here we are talking about composite numbers. Composite numbers means those numbers which have more than 2 factors, right? And we know that 6 is a composite number as it has 4 factors, 1, 2, 3 and 6, right? So now let us take an example of 6 here. Now, and we are representing it as, we are expressing it as product of primes. How? We know that we can write 6 as 2 multiplied by 3, right? Now see carefully. What does this first line means? Every composite number, we took the composite number 6, can be expressed as a product of primes. We are expressing it as a product of primes. 2 multiply 3, you can clearly see that 2 and 3 both are prime numbers. So is it clear that we can express the composite numbers as product of primes? Let us take one more example. If we talk about say 15, we can write 15 as 3 multiply 5, right? Here 3 and 5 both are prime numbers. So this sentence satisfies the thing that every composite number can be expressed as product of primes. Now see next thing, and this factorization is unique apart from the order in which the prime factors occurs. What does it mean? See, we factorized 6 and 15 as the product of primes. Now this factorization is unique. Unique means we can write 6 only as the product of these two prime numbers, right? 2 and 3. There is no other way to write 6 as the product of primes. Apart from that if we change the order of these prime numbers 3 and 2, 3 multiply 2, means we can write 6 as 2 in 2 ways, 2 multiply 3 and 3 multiply 2, right? But it is unique means here only the order of these primes changes, but the factorization is unique, means there are no other factors we can use to show 6 as the product of prime. Clear? Now this is the fundamental theorem of arithmetic, means in the similar way we can express every composite number as a product of prime, and that factorization is unique apart from the order in which the prime factor occurs. Let us take one more example. See 16. We can express 16 as product of primes as 2 multiply 2 multiply 2 multiply 2. If we multiply 2 4 times, then we will get 16. And there is no other way to write 16, to express 16 as the product of primes, right? Similar way, if we talk about 12, then we can write it as 2 multiply 2 multiply 3. Here 2 and 3 both are the prime numbers, hence it is the product of the prime numbers, and there is no other way to express 12, right? Similar for 50, 2 multiply 5 multiply 5. We can change the order of these primes, but these factors remains same. Now Similar in the case of 100. We can write 100 as 2 multiply 2 multiply 5 multiply 5. Only 2 times 2 and 2 times 5. We can use these prime numbers only to express 100. We can change the order, but it can be expressed as these product of these prime numbers only, right? Similar in the case of 450. See, we will do the prime factorization of 50 first. 450 first. It is 2, 225, then 5, 5 4 is 20 and 5 5 is 25. Then it is 5 9, then it is 3 3 and then 3 1. It means we can express 450 as 2 multiply 5 multiply 5 multiply 3 multiply 3. We can use 1 times 2, 2 times 5 and 2 times 3. These all are prime numbers, and we can express 450 as the product of these prime numbers only. Also, we can change their order, but the factors will remain same. Means the factorization is unique. It is the fundamental theorem of arithmetic. Clear? And from this theorem, we get one thing, that composite number is equal to product of prime numbers. This is just the same thing we are using in the fundamental theorem of arithmetic. Clear? Now see the next. There is a question. The question says, consider the numbers 4 raised to the power n, where n is a natural number. N is a natural number means n equals to 1, 2, 3, 4 up to so on up to infinity. These are the values of n. Now we have to consider the numbers as 4 raised to the power n. What is the meaning of 4 raised to the power n? See, we can take any value of n and hence we will get the value of 4 raised to the power n. Means for n equal 1, 4 raised to the power n is 4 raised to the power 1. For n equal 2, it is 4 raised to the power 2. For n equal 3 is 4 raised to the power 3. For n equal 4, it is 4 raised to the power 4 up to so on. Now, what is the value of 4 raised to the power 1? It is 4 only. 4 raised to the power 2 is 16. 4 raised to the power 3 is 64. 4 raised to the power 4 is 256 up to so on. Right? Hence we get the values of 4 raised to the power n. Now see the question again. This is the first sentence. We have to consider the numbers 4 raised to the power n, where n is a natural number. So for n as natural numbers, we get the values of 4 raised to the power n. Now check whether there is any value of n for which 4 raised to the power ends with the digit 0. We have to check, is there any value of n for which we get the value of 4n as the unit digit 0? See, we have checked that. For n equal 1, the unit digit is 4. For n equal 2, unit digit is 6. For n equals 3, unit digit is again 4. For n equal 4, it is again 6. It will continue now. For 5, it will be 4. For 6, it will be 6. For 7, it will be 4 again, and it will continue up to infinity. Right? It means the values of 4n for any natural number, it ends with 4 or 6. It ends either with 4 or 6. It means there is no value of 4 raised to the power n which ends with digit 0. Right? You got to know this? Now, let's see how can we write this thing as the solution. Okay? You can write it in this way. See, if the number 4n for any n were to end with digit 0, then it would be divisible by 5 and 2. Means अगर हमारे पास कोई नंबर 4 raised to the power n है जहां पर n नेचुरल नंबर है और उसको 0 डिजिट के साथ एंड होना है, मींस उसके आंसर की यूनिट डिजिट 0 होनी चाहिए। अगर 0 होनी चाहिए तो हमारे पास उस नंबर के 2 फैक्टर्स होंगे। जो वो 2 फैक्टर्स कौन से होने चाहिए? 2 and 5, राइट? क्योंकि अगर हम 10 ले रहे हैं तो इसके फैक्टर्स 2 मल्टीप्लाई 5 होते हैं, ये 0 से एंड हो रहा है। इफ वी हैव नंबर 20 then the factors are 2 multiply 5. It also must have the factors 2 and 5. So from here we get to see that any number that ends with digit 0 must have 2 factors 2 and 5, right? Now so if the number 4 raised to the power n also has to end with digit 0, then it must also have these 2 factors 2 and 5. It means the prime factorization of 4 raised to the power n would contain the prime 5 if it ends with 0, right? But we can see that we can write 4 raised to the power n as 2 multiplied 2 whole raised to the power n, right? 2 into 2. We can write 2 multiplied 2 as 2 square. I am writing it here as 2 raised to the power 2 and that whole raised to the power n, right? And also we know that a raised to the power m raised to the power n is equals to a raised to the power mn. So from here 2 raised to the power 2 raised to the power n is equals to 2 raised to the power 2n. It means 4 raised to the power n is equals to 2 raised to the power 2n, right? This shows that the only prime in the factorization of 4 raised to the power n is 2. From here we can clearly see that there is only one prime we are using in the factorization of 4 raised to the power n, that is 2. It means there is no factor 5 in the prime factorization of 4 raised to the power n, right? So by the uniqueness of fundamental theorem of arithmetic guarantees that there are no other primes in the factorization of 4 raised to the power n. Now think about the fundamental theorem of arithmetic. What does that say? It says every composite number can be expressed as a product of primes in a very unique manner, in a very unique way, right? That factorization must be unique. It means there is no other way to express that composite number, right? So according to that we can't express 4 raised to the power n in any other way, right? So we can say that there is no natural number n for which 4 raised to the power ends with digit 0. Clear? Is it clear? Now see the next question. Here we have check whether 6 raised to the power n can end with the digit 0 for any natural number n. It is the same type of question as we did earlier. See, 6 raised to the power n is given now. Now here we have n as natural numbers again. So they must be 1, 2, 3, 4 up to so on, right? Now 6 raised to the power n is 6 raised to the power 1, 6 raised to the power 2, 6 raised to the power 3 up to so on. 6 raised to the power 1 is 6 only. 6 raised to the power 2 is 36. 6 raised to the power 3 is 216 up to so on. From these numbers you can clearly see that in 6 unit digit is 6 only, in 36 unit digit is 6, in 216 unit digit is again 6. It means every value of 6 raised to the power n has 6 as the unit digit. It means 6 raised to the power n cannot end with digit 0, right? Is it clear? Now see how can we write this in the solution. If the number 6 raised to the power n for any n were to end with digit 0, then it would be divisible by 5 and 2, right? If the unit digit must be 0, then it must have the factors 2 and 5, right? That is, what does it mean? The prime factorization of 6 raised to the power n would contain the primes 5 and 2, right? अगर 6 raised to the power n के पास यूनिट डिजिट अगर 0 होना चाहिए तो उसके लिए ये ज़रूरी है कि वो 5 और 2 से डिविजिबल हो. 5 और 2 से डिविजिबल हो, इसका मीनिंग क्या है कि 6 रेज टू द पावर n का प्राइम फैक्टराइजेशन जो हो उसमें प्राइम्स 2 और 5 होने चाहिए, राइट? बट वी नो दैट 6 is equals to 2 into 3. Also we can write that 6 raised to the power n is 2 multiply 3 raised to the power n. From here we can see that 6 raised to the power n has 2 as its factor, but 5 is not its factor, right? This shows that 5 is not in the prime factorization of 6 raised to the power n. Hence, for any value of n, 6 raised to the power n will not be divisible by 5. तो हम यहाँ से कह सकते हैं कि n की चाहे कोई भी वैल्यू हो, 6 raised to the power n 5 से डिविजिबल नहीं होगा. और अगर वो 5 से डिविजिबल नहीं होगा, हमने यहाँ देखा कि अगर उसका यूनिट डिजिट 0 होना चाहिए तो वो 5 और 2 दोनों से डिविजिबल होना चाहिए. यहाँ हमने देखा कि वो 5 से डिविजिबल नहीं होता. It means 6 raised to the power n cannot end with 0 for any natural number n. तो यहाँ से हमें पता चला कि 6 raised to the power n 0 डिजिट से end नहीं हो सकता. Clear? So that was all for today. We will discuss the next topics in our next video. Till then, have fun and like the video, subscribe the channel and do as many comments and likes as you can. Okay? So bye bye. Thank you.